Hi everyone, welcome to Java session 2. So where we have covered some of the basics in the earlier session. So now we will be covering the rest of the topics and let us recap in a quick way. So I'll take a little bit fast video now because it's taking too long time to explain so you could understand. So introduction was completed and introduction to object-oriented versus process-oriented was completed and what's a class we understood and what is an object also. I hope you are clear. So whenever Java program wanted to learn, there is a main thing we wanted to concentrate is what is a class and what is an object. And both are very important entities here. So class contains the code, object contains the data. So there must be both relevant. So there is when class is not there, there is no object. When there is object is needed, if class is not there, no object. So both are necessary here for object-oriented programming. So let us jump on to the next topic. Um, I hope you have seen this. Next topic is um, there are features of Java, features means features are principles that are more relevant here. So first one is abstraction. So abstraction is one of the concept here. Abstraction, it's a feature and represent essential features of a system without getting involved into the entire system. For example, so when object is created, like there is a standard class of Java. So with that object we create, we don't see the details. So we see only the behavior. Okay. So in real world objects also you see lot of objects are surrounding our world, surrounding us. Though what happens, the object behavior we know. So when we go and purchase a TV, we just see essential features. We are not going to open the entire TV and we verify each and every integral part. So that way, any object, you buy a mobile phone, you buy a TV, you buy any system, anything, real world object, even purchasing a mango at least. We just verify the taste. We don't get into the integral parts of every object. We see only the abstraction, that is essential features. So that way, that is called abstraction here. This is one of the best feature here. And next thing is message. So when object you wanted to get interaction, you wanted to get interaction from any object. Suppose there is a TV. When it is going to interact with you, when you switch on and operate with a remote, then only it is possible to get its behavior. Okay. When there is an object, what we expect is we wanted to get its behavior. You take a TV, you take a light, you take a fan, you take a mobile. When we pass a message, then only there is an interaction from the object. Either any real world object you take or a software object you take. Okay. So message is also very important. So which is interacting to the object. Okay. So we have the details here on the right side. So you can observe here. So Java features and principles. So next one, there are three main principles of Java. One is inheritance. Second one, encapsulation. Third one, polymorphism. So these three features are making Java proud and in a extraordinary way. It is there is no other language which has this kind of features. Okay, we have some limitations in other languages, but whereas Java is highly popular using these particular principles. Okay, first inheritance. What is inheritance? So when Java was started on 1.1, there was a little low features we were having. Now Java is advanced. Now a lot of ready-made packages, ready-made classes, ready-made functions have been improved in Java. So when we create a class, we will just use that object and we will invoke that particular function what is already there in ready-made way. And we will invoke it and we will get its behavior. Suppose you wanted to find any numbers a square or a cube. Okay, then what you will have to do, you just give a base number and a power number. Mat.power 10 comma 2, 10 comma 4. So what happens? It is going to find the square or a cube or a power of whatever the number you give of 10, it is going to find in quick moment. So that class is already been developed, that class is already there where you are just using it. So that way, Java has hell of classes. hell of functions. So you can use them in your class. So you are inheriting properties of other class into your class, though it is working very well. So what happens? It is not only that. Any such product when we design. So we will create a class and we will keep some functions in that and we can give it to someone and we can make it to inherit by other class. So it is not needed to rewrite again and again by other languages. So that is a great feature and a principle you can say as an inheritance. Next, encapsulation. So encapsulation is such a feature. So wrapping the data, like any system which is developing in the market, for example, like any system. Suppose there is an ATM machine. ATM machine, so there is a public use and a private use. So when public use, like a single user will go and use the ATM card and take the money and use the balance and change the PIN code and updating the phone number. So these are going to happen. So that's called encapsulation. It is not only the public use, there is a private use. So the bank officials are going to assign a third party who is going to go to ATM and insert the money by opening the ATM by using three different series of codes using their private card, which is going to be handled over by the bank officials. So what I mean to say is when they properly keep the money and they take a trial and then we are going to use that for public use. Not only that, anything any software which is developed that will be used for public and that will be used for private. Okay, so that way we can encapsulate the data. So what is to be restricted, what is to be given to the user, means what can be public use, what can be private use. So that way we can um, understand, we can develop the system, we can develop the software. So that way encapsulation is the best feature here, best principle of object-oriented programming language. Polymorphism. Polymorphism means many faces. We can, in Java, one thing is everything is a mnemonic way. Mnemonic way in the sense, by name only we can understand what is the behavior. For example, man.sqrt, square root, man.gbrt, cube root, man.ceil, raising up, so whatever the functions are there, not only mathematical, any related functions we have, so those are created based on the name, based on given name. So polymorphism is developed, polymorphism in the sense we have the same name, multiple functions. Okay. Like it is also called as method overloading. Okay. Method overloading. So multiple functions with the same name by differentiating with the parameters and by differentiating the type of parameters and the order of parameters and what do you call type of when number of parameters are same, it must be number of parameters differed. When number of parameters are same, type of parameters to be differed. When type also same, then order of parameters must be different. Then it is a valid function overloading. So that way, polymorphism is one of the major principles of object-oriented programming. So these three principles are a great principles of object-oriented programming to develop the code. So, so I think this is completed, this page. I'm going to the next page. That is page number 5. So this has been prepared for the students. It is used for minimum, like, school students, as I mentioned, and as well as for colleges and as well as for education purpose. It's not like a big programming. These are fundamentals. Fundamentals are very good and you can watch and understand. So here there is when we write a program in Java, so that is called as a source code. Source code in the sense in our language, there are multiple syntaxes we have, like statements we use and functions we use, keywords we use, identifiers we use, and operators we use, and many things we use, and we will frame a program. So that is called a source code. Source code will be in English language, and as soon as you compile, it is converting into byte code. So every compiler will verify every time when you compile, a program will be verified, and after that, it is going to convert into bytecode, and bytecode is the one which is used to execute your program and give the output. Okay, so this is helpful for um, you know there are two different files will be created. So when you create a program, so that is stored in a file name as .java. Okay, suppose program you created, that is student.java. Then immediately when you compile, it is going to create student.class. So bytecode will get automatically get created, and which is in machine language where we don't understand anything about it. Okay, so there are some differences we have here. Let us check those. One, it's a collection of computer instructions written in human language, readable language called programming language. That's what I said just now. Next, it is an intermediate code between source code and machine code, and that is executable by virtual machine. So this is a um, it is a source code. It is generated with the help of source code. When source code is not there, this is not there. Okay. This is an intermediate code, we can say. And object code is also there. That is different. The source code is in form of plain text with a syntax and comment similar to English language. So where just now I said before. Next, the bytecode has numeric codes, constants, references, and encode the results and parsing and semantic analysis. So where the bytecode has numeric codes, it is converting almost machine language, but we don't try to understand that. We don't understand that. That's a fact. Okay. Next, the source code is not directly executable by the machine. So when you write a program, it must be compiled. When you don't compile, it is not possible to execute. So what happens? You must compile that. The object bytecode is going to be created. So until and unless you don't compile, there is no bytecode program is going to be created. This is a separate file. That is a separate file. Why? Because compiler is going to verify the program errors by whatever written by you, and then bytecode program is created. So that is created with a dot class. So, when fourth difference, the speed and the source code is minimum than the bytecode. Speed in the sense, when you write a large program. So speed in the sense when you execute it. Compiler has to check everything, right? So that's based on the machine's performance as well. So that way it is going to be executed. So the speed of bytecode is faster than source code. It is once it is source code, you compile it and bytecode is created. And this is very faster. This is dependent on a machine, and machine speed also will help here. And it is executable code. Okay. So this is faster than the source code. The performance of source code is not much as compared to bytecode. So it is not that much performance is high here, and the performance of bytecode is higher than the source code because it is close to a machine code. So these are the main differences here between source code and bytecode, and this will be helpful for understanding theoretically. Okay. And programmatically, this is not that much helpful because we are not going to involve into the execution part at all. We must be very good at syntaxes, and we must be very good at writing a program lines, statements. So this must be evaluated in that way. Next, I'll cover only 3 pages per day per session, so I don't go more than that. Next, one more here topic is Java features. So in which way it is helpful and advantageous to other languages. So there are high level I will go with. So simple, it is easy, understandable, and basic concept. Java, why it is easy? Because it is like interfaces, packages, okay, and after packages, classes, in classes after that, methods. So everything is in Java in form of method, in form of class. We invoke them and we use them. Okay, so that is what we have to understand and follow with. So that way Java is very simple to understand because its concepts of object-oriented program is simple. Next, robust elimination of error prone situations. Whenever error comes, we can eliminate it very easily. That modular, in the sense, Java program is developed in module based. So when we develop module based, so function, suppose where we have error in that function, we will find error there, we will rectify there. It is not needed to disturb the entire program. So that is one of the great advantage. That's called robust and security. Secured. So Java is, the property of encapsulation. Encapsulation we develop privately, publicly. So that is protecting the data. So that way it is secured. And object-oriented concepts. Next, fourth one. Okay. So fourth one is like in Java, elements of objects and supports um, with object-oriented features of abstraction principles. So these are principles as we discussed before. So that way it is highly advantageous and platform independent. Java is allowing you to write code in any operating system. There's no restriction here. You can write in Unix, you can write in DOS, you can write Linux, you can write in Windows, you can write in Notepad, and you can write in Word. So, and we have a lot of IDEs also. We will write and we will execute in any of operating system. That's the reason it's a platform independent language. Like other languages like C++ and C are dependent languages. And architectural neutral, Java compiler generates an architectural neutral object which makes compiled code to the executable multiple processes to presence of Java runtime system. So this is anywhere when you write in one machine, so it can be executed anywhere. Okay. So one more page we have of Java feature is a portable. Java architecture is neutral, has no implementation dependent on aspects. Okay. Next is dynamic. So dynamic Java programming can carry an extensive amount of runtime information that can be used to verify and resolve accesses and objects at runtime. Java is considered to be more dynamic than C and C++ programs. So multi-threaded. Java has one of the great concepts here, like multi-threaded features here. Okay, so multi-threaded makes it possible to write programs and that can many tasks simultaneously, multiple tasks simultaneously. So in high performance. Okay, Java features allow you to have high performance and use just runtime compilers. Next, interpreter. Java bytecode is not stored anywhere and it's translated to machine instructions. So these are Java features. We have here five on first page and second page five. These are 10 features of Java are making Java in a high level. Okay. So try to understand the theory. It will be helpful for you, maybe for your examinations or I'm already telling you like it is for student level, for schooling, those who are starting coding, who are having, and maybe if it is not like, in BTech or BSc, wherever you have computer related fields, we will jump into the program soon, very soon. Okay, there are two to three more sessions will be there, and after that we'll be jumping on to the programming. Okay. Next, we will be discussing about the values and types and tokens. So what are the symbols and what are the entities we'll be using in Java? So these all are those. I'll be covering those in the next session. So that's all for the day. Have a nice day, everyone. Thank you all for joining and thank you all for watching this video and do like, subscribe and share. Thank you all. Bye bye.